I wanted to take a moment to bring some of the ideas that we've talked about together and see how some amazing discoveries can be made when you do put some of these amazing ideas together. An astronomer by the name of Andrea Getz, who won the Nobel in Physics just last year, made an astounding discovery along with a team. And here's how it worked. They made observations to the center of our galaxy. And they noticed at the center of our galaxy there are a number of stars with very eccentric elliptical orbits, like so. And they all seemed to be orbiting this one central point. But they couldn't see anything there. But they could measure their orbits and the periods of those orbits. So they were able to determine what the radius of the orbits were and what the periods of the orbits were. Well, you remember this guy? Newton's version of Kepler's third law. All right. That means mass. Well, what were they able to measure? Well, they were able to measure period. They were able to measure the radius of the different orbits. And so now they could do something like this. Oh, I wrote that wrong. That's p squared. So, yeah. So there you go. If you know the period, if you know the radius, use the universal gravitational constant, well, pi, that's not going to change. You can figure out the mass of the primary. And so they did. They measured the periods of these stars. They were able to measure the radii of the different orbits. And it turned out this object, whatever it was, had a mass of somewhere in the neighborhood of 4 million solar masses. And there's only one kind of an object that can have that much mass. We know that stars can't have that much mass. What can have that much mass? Only one thing, a black hole. And there it is. That's how they were able to determine there was a black hole in the center of our galaxy and how big it was.